Hello to you all, this is Hamid Rezadusti alongside. We'll be performing the Standard Proctor Compaction Test. But before we start the experiment, let's see the equipment that we're going to use for this experiment today. Right in front of me we have the mold that we're going to use. On my left we have two balances with the same precision of 0.01 gram. We have the hammer for this experiment, the standard hammer of course, which is different from the modified one. We have the plastic squeeze bottle of water, filled with water of course. Right here we have the empty flat pan. We have a sieve of measurements 4.75 millimeters. Right here we have the gel that we're going to use at the end of the experiment. And we have the soil sample, and that's it for now.
Now we are starting our experiment with my partner. First of all, we have to break all the lumps of our 4.5 kilogram soil. And now we go to the next step.
The next step, we'll pour the sand, trying to pass it from the sieve. At the same time, we'll shake the sieve so that everything could pass from it. As you can see, the coarse grain particles will remain and the fine grain particles will pass, which is actually our point of focus today. That compaction only applies to the fine particles. Okay, so after passing it from the sieve, we wait to see how much sample we have actually. So we have about 4 kilograms here, which means actually 1 kilogram is because of the pan. Yes, so will be about 3 kilograms of the sample here. So the next step is to add about 5% water to obtain moist soil. We're controlling the weight at the same time to see when it reaches 5% of water, which is about 150 grams. The next step will be to mix it up to obtain a uniform sample. So the next step is to measure the mass of the base plate and the proctor mold. So it's about 4,282 grams. So after writing the mass, the next step is to attach the extrusion. But we have to pay attention to this, that while we're measuring the weight of the proctor mold and the base plate, we didn't add the extrusion. Okay? So, after attaching the extrusion, let's make it sure. Okay. We add the soil in 3 layers and we compact it at each point. So as mentioned before, we try to fill it with 3 layers and compact it at each step. So after that, we try to use a hammer and stroke it for 25 times in order to obtain a compacted soil layer. And now we add the second layer. So again, we use the hammer to try to compact the second layer. And we add the last layer to the mold. And now we use the hammer for the last time to perform the last layer of compaction. Again for 25 times, of course. So on the next step, we remove the extension, as you could see. And after that, we use a steel straight edge or a knife to trim the excess soil. Above the soil, of course. So the next step is to determine the weight of this, but the point that we shouldn't forget is that this is also the weight of the moist soil, the compactor mold, and of course the base plates. So we get the measure of equal to 6,048.5 grams. After this step, we remove the base plate from the mold, as you could see. And shortly after, by using a jack, we extrude the compacted soil from the mold. As you can see, we're trying to separate the moist soil, the compacted soil, of course, from its mold.
Now we are going to determine the weight of the moisture can. Now it is exactly 60 grams.
60 grams will be our WB3. 60 grams. So after measuring the mass of the can, we place the compacted soil and we try to determine its mass, which is exactly 236.5 grams. 136, sorry. And the next step, which is also the final step, we place the moisture can in the oven. We have to wait like about a day, which is like 24 hours, in order to obtain a constant weight, of course. And then it will finish.
Thank you very much for watching.
We'll be shortly back with the next experiment.
Thank you, sir.